Hello, I hope you all remember where this theme comes from. It's X-Files movie, famous some time ago. This movie told us that the truth is out there. But for us in the construction business, this message is a bit less than enough. So the topic of this presentation would be, can we ever find our single source of truth? People have been seeking truth for millennia. It was not always successful, but even if it was, that truth found might not always be nice. And that's especially true if you're talking about the truth of project information. Now, why is it so? That's because for something as complex as a construction project, which involves many stakeholders, there are typically various paths of seeking truth. And the truth found this way may be subjective, depending on who you ask. With time and with complexity of our projects, the communication lines may become even more convoluted and result in conflicting and unreliable information. I'm pretty sure all of us had a chance to experience this at some point of our career. This is why the concept of the single source of truth appeared to simplify communication and provide a truly reliable source of information. Single source of truth is supposed to be the heart of the project, and all the parties, when all the parties constantly provide their input and view the input of others. So let's look what should be the main features of a single source of truth. All contents, all information exists in one place. All contents is also developed and reviewed in this single place. Every party has access to the latest versions of the contents, obviously based on their access rights and privileges. So CDE has to be equipped with access, with a mechanism of access control. And all publishing occurs from this single place. This guy, which you see on the left-hand side, probably an architect or a BIM manager or project manager, has been looking for a long time, far and wide, for his single source of truth, only to learn from this great sage that what he really needs is a common data environment. A term that I'm sure all of you know. So now it's time to ask, is CDE really a single source of truth? So should we have one CDE or many? Let's look at what some of the important players in the market think about that. BSI, British Standards Institution, the organization behind the famous standard PAS 1192, now superseded by ISO 19650, states that common data environment is a single source of information for any given project used to collect, manage, and so on. So it is a single source of information. ASITE, one of the digital engineering consultants, maintains that common data environment is a single source of truth for a project, as simple as that. RIBIM, another technology innovation consultant, according to them, CD is an essential part of BIM, acting as the single source of truth. Oracle, global database technology leader, they say that CD is a single source of project truth as well. And National Building Specification from UK also defines a CD as the ultimate source of truth. Why truth is actually in quotes on their website, I'm not sure, but I hope it's real truth. However, when we look at the international standard ISO 19650, which is kind of a Bible for most of us in the digital project management of digital management of information, things are not that obvious anymore. This standard, for those who are not familiar, is commonly used to implement BIM. We also use it in Hong Kong heavily. Its definition of CDE states that it is an agreed source of information, but they don't state anywhere that it's single. This is because the authors seem to assume, and I would say rightly so, that the ideal CDE may not be easy to implement in practice. Of course, not easy doesn't mean impossible, but still, they, following this this idea, they introduced the concept of multiple CDEs, a project CDE, which should be really the only one, and so-called distributed CDEs owned by different delivery teams, for example, discipline teams. Distributed CDEs need to transfer metadata to project CDE in order for the whole system to work properly, because what we need is the updated information in a source that is accessible to everyone. What is metadata? For those who may not be sure, that is just attributes, a set of attributes for information like name, author, revision status, submission data. There may be much more. Now, interestingly, recently issued guidance, a thick book for ISO 19650 states that in reality, this transition of metadata is often a manual process.
What?
A manual process, and in practice may not always be possible. So it's clearly, we can clearly see that there is a gray area, even in this, in the ISO 19650 standard, over what the CDE really should be and how to implement it. This is an example from the guide in question, which shows how from a distributed CDE, metadata would have to be transferred into project CDE, which looks pretty complex, if not scary, especially if it's going to be done manually. As in information management, we definitely do not like to do things manually, and manual processes like typing. They actually state in the guide, in ISO 19650 guide, that it may be, or it is, in practice, a manual process, which sounds really, really scary. Because given all this, one project CD should be really the first thing to try to attempt, before attempting more complex solutions of multiple CDs. When we have one project CDE, then we are absolutely sure that all the delivery teams communicate according to the same protocols, and all the information containers use the same metadata. Information container, by the way, is just a package of information. It's most of the times in our practice is just a file. Computer file is an information container. One example of it. The common metadata include information lifecycle states. That's what was mentioned before as work in progress, shared, published, and archived. But also revisions, revision management, status codes, or also known as suitabilities, various security settings and access settings, and integrations with applications if there is any. And in a proper CD, there should be. And much more. Now, this is the best solution until one day we have something called an open CDE standard, which effectively mean that all the CDs in the world, let's allow ourselves to dream, could communicate with the same protocol, and that would eliminate the issue of interoperability of metadata. At the moment, unfortunately, there is no such standard available. Building Smart International began doing some work around that, but it's a very, very initial stage. So once we decide whether we have many or one CD, we need to think if all or just some project information should be stored in the CD. So let's look again what the big players' opinion is about it. BIM Plus, digital construction resource of the Chartered Institute of Building from UK, state that CD is not just for a place to share geometric information. other information such as registers, schedules, contract reports, and so on. NBS, again, National Building Specification, defines CDE as something not limited to assets created in a BIM environment, and which will eventually include documentation, graphical models, and non-graphical assets. Similar with Autodesk, one of the global software providers, which I'm sure all of us know. They state that CDE can include anything from project contract, schedule, change orders, and more. So it looks like, indeed, all those trendsetters agree that CDE should truly be a place for the whole information about the project. Let's look what it translates to in a little bit more detail. We know that the main source of project information is the information model. That's the name which, in the industry, by which we mean a BIM model, commonly used term. BIM is here a building information management to avoid the building information model problem. This thing includes a proper 3D model plus a lot of data. Emilia talked about so much. And during the project, there is a lot of design output from this information model, be it graphical information, drawings, 3D views, animation, and so on, or non-graphical, schedules, calculations, drawing lists, and many more. Obviously, all this output needs, this effectively makes our CDE the source of all design data, and all these design outputs obviously need to go and be stored into our command data environment. But there's more. A lot more information about the project, not traditionally, at least traditionally, generated from the model. Within the organization, it can be contracts, emails, design sketches, etc. And from outer external stakeholders, we can have comments from consultants, reports, approvals by statutory bodies like government, etc. And following the model of all the data within a command data environment, all this information should also be stored in our CDE, making it effectively a source of all project information. After going through this thought process, when establishing our CDE, we have to decide how our CDE will be physically, and where will it be physically hosted. Will it be hosted on our premises, within our organization, or in cloud, provided by external providers? In case of a cloud-based solution, our single source of truth will be moved somewhere to a remote server, likely beyond our control and beyond our jurisdiction even. But still, even if it's a cloud solution, as compared to a on-premises solution, it's still a centralized CDE. And the centralized CDE means a single point of failure. In the worst case scenario, this may happen with service outage if something goes wrong with this single point of failure, and actually the single point fails. And if not this, we can have service slowdowns, and things like that happen. This, what you now see on the slide, besides of a nice graphic pattern, is a screenshot from a service health dashboard of one of the major providers of cloud solutions. As you can see, those service breaks do happen. On 24th of October, we had a number of cloud services. Horizontal lines are different cloud services. We had a number of cloud services unavailable, and in particular, one of them was not available within 7 days apart from each other. So this is not something we would like to see. There are more threats coming from cloud storage, and one of them is vendor dependency. So the data owner may not always have full control over his data, which is located somewhere remotely. That may make the owners of sensitive data, especially like governments or military organizations, or even big infrastructure developers a bit uneasy. And another problem with this is that in case of any problem with this one vendor, migrating data to another vendor is difficult and sometimes impossible. Security and privacy, a very pressing issue. It's worth noting that $3.5 billion was lost in United States only due to cybercrime in 2019, according to FBI. Some other statistics give much higher numbers, but let's stay with ABI, a very truthful agency. And sensitive project information may be vulnerable to attack, and it is. So let's wonder whether there may be any other solution which would eliminate problems like this single point of failure, lack of control over our own data, yet be secure, trustful, and efficient. And there may actually be such a solution. Enters distributed ledger technology, or blockchain. Sorry, not blockchain. Blockchain. So what is blockchain? Let's first explain what is a ledger. Ledger is a type of register, simply a list of events or transactions commonly used in accountancy. Traditionally, for an organization, say with many branches, every branch edits records in its own register. Edited records are then added somehow to the central register, a separate register, and then everyone can view new records in the central register, again, provided that he or she has the right access, the proper access rights. Now, with a distributed ledger or blockchain, the situation is a bit different. Well, actually, a lot different, because everyone edits a record in his copy of the whole register. So every stakeholder holds the same identical copy of the whole thing. New record is sent through the network and approved, and then everyone's copy of the register is automatically updated. So it's like a distributed single source of truth with many copies, multiple copies, but those copies are automatically in almost real time synchronized, ensuring the same identical and most updated contents. All this is possible to a clever mechanism behind blockchain implemented with clever code. So this shows how this coding is important, and it's an example of situation when the lowest level of technology, which is coding, can truly revolutionize the very top level of business processes. Now, what may blockchain be for BIM? Let's do a simple thought experiment. If I replace this register with a building, or sort of, and then those separate registers with disciplines, and change wording a bit, we will have a situation when everyone edits his discipline model, edited models are periodically federated, and then everyone can view changes in the federated model, which brings us to a definition of BIM level 2. So that's a traditional register, traditional ledger. Now, what happens in case of a distributed ledger? So we do the same thing, replace the register with a model, but implemented or stored in a blockchain, and those registers by copies of this model with every party. What happens then is that everyone edits his part of his copy of the single project model. Design change is sent through the network and approved, and then everyone's copy of the single model is automatically updated. Now, this sounds like a definition of BIM level 3, single model containing all disciplines and edited at the same time by various parties. So that means that, among other things, blockchain can be the enabler of BIM level 3 that we all strive to achieve. But there's more. Blockchain mechanism ensures a distributed secure cloud storage and elimination of single point of failure. Therefore, built-in approval mechanism for any information being transferred. Any information obviously may mean design changes. Trusted, immutable, time-stamped time-stamped record of all project changes and events. Very, very important thing for projects and for very important functionality of CDE. And right to edit and ownership of information always with the authoring party. Also one of the issues which for years has not been solved within the BIM industry. For example, when somebody does a very, very complex family or component and includes it in the project, it's available to everyone, for everyone to see and use without any ownership rights and without any protection of intellectual property. Based on those features, blockchain can enable so-called smart contracts, one of the most promising uses of blockchain, which are based on if-then conditions secured in the blockchain and can be executed automatically. For example, within in the design stage, when the design package is submitted, it's checked from various points of view by the client, and then smart contract logs those changes and executes itself automatically, releasing payment. Similarly, in the construction progress, when the last piece of structure is positioned on site, it's verified by GPS acting GPS device acting in this situation as a so-called oracle, and then automatically the BIM model, as-built BIM model, is updated automatically, and the change is recorded in the blockchain, and again a smart contract based on those two information, updated model and GPS positioning confirmation, releases payment. Now, the ultimate future use, possible use of a blockchain can be digital twins, which means that using this technology, as-built information can be constantly fed into the model through sensors, and what effectively would make a BIM model as is rather than just as built, and that would enable a true digital twin. So, can blockchain technology be the ultimate method to implement a true single source of truth, or this holy grail that we are all waiting for? It's pays to be always cautious, like with any new technology. It pays to be open for changes yet cautious, so as not to get hurt early in the process. As you can see, happened with this guy who put too much trust in the technology of virtual reality. So with blockchain technology, let's stay cautiously optimistic. Thank you very much.